The questions we want to answer are, what are the full and valence electron configurations of two different atoms? We'll start with thallium, element number 81. As you can see, it's right here on the periodic table. So what one does is one goes up a row to the nearest noble gas. So we know that it starts with xenon. And then we start working in the row that the thallium is on. So let me number the rows. 1, 2, 3, 4, 5, 6. Okay, so the first two electrons are in the s block, so that is 6s2. Now, don't forget that the d block is going to be the row number -1. But, as you can see, we have a little something going on here where it goes from 57 to 72. So it also passes through the F block. It is traditional to mention the F block first because most of those are lower in energy. So remember that the F block is going to be n-2 for the row number. So that would be 4F14, and now the D block is going to be n-1, so that will be 5D10. And now we're finally to where the thallium is, and this is going to be in the P block, because the P block, of course, starts right here. So the thallium is going to be the original row, which is 6P1. Now, if we want to do valence, we simply have to select the outermost S, that'd be this one, and any partially filled orbitals. So that would be the 6p block, which does not have 6 electrons but only 1. So the valence for this would be 6s2, 6p1. Okay, now let's try and work on manganese. Manganese is right here. So once again, we're going to go up a row and over and start it with argon. So it will start with argon. I already have my rows numbered, and we can see that we are in row 4 in the S block, so that's 4s2. And now we want to count the D block, and of course there are 1, 2, 3, 4, 5 of those, and don't forget it's n-1, so that would be 3d5. Now, as far as valence goes, we're going to use the same formula. We want outermost S and partially filled orbitals. So that would just give us a valence of 4s2, 3d5. And that's all there is to it.